My name is Parag Kachare. I'm the technical director at Esmil Process System. Esmil has been based in High Wycombe, UK for over 40 years. We specialize in providing solutions for the industrial water and wastewater treatment with extensive expertise in the wide range of membrane technologies and their application. Esmil has developed and supplied a treatment solution for various challenging wastewater streams that including produced water from the offshore oil and gas, MDF factory wastewater, acidic wastewater from the petrochemical industry, digestate from the anaerobic digestion plant, and effluent from the food and beverage industry. Currently, Esmil is collaborating with ZwitterCo on multiple applications. Today, I will briefly present two case studies where original membranes were replaced with ZwitterCo RO membranes, resulting in the significant benefits for our customer. This particular case study is for the effluent from food and beverage industry. Originally, the water was used to be tankered off-site to nearby anaerobic digestion plant. With the Esmil plant, fraction of the feed volume goes to the AD plant, which reduces the transportation costs significantly. Prior to this project, there were few technologies offered to the customer, and the technology comparison was carried out. The Esmil process tick all the boxes with respect to the feasibility analysis as compared to the biological and evaporational process. Evaporation process, as we all know, is a energy and expensive process, whereas the biological treatment is very sensitive to the variable feed and the large footprint requirements. This slide shows what was the design characteristic of the feed and what we actually seen when we started the commissioning. The COD was high in the first place itself, so we had to do long-term comprehensive trial. But when we started the commissioning, the COD was found almost 3 times higher than that. Because of that, we countered issues using our original membrane, non-Zwitter ionic RO membranes. It was struggling to keep up with the design values in terms of the recovery and the cleaning frequency. So Esmil decided to replace the membranes, the standard membranes, with the ZwitterCo RO membranes. Some of the pictures from the site during the installation stage. Okay, as I mentioned earlier, the membranes were replaced, and we had the team from ZwitterCo. He helped us troubleshooting the conventional membranes. So you can see we did a on-site autopsy of the membrane. We noticed a lot of solids, some issues with the membrane material and all, and we immediately decided to go with the ZwitterCo RO membrane. So as this project is it's a non-standard project, very high COD in the field, so there were some challenges. So I have compared here what we achieved using from the original design and what we achieved after replacing with the ZwitterCo membranes. So high organics restricted the recovery to 65%, whereas after the membranes were replaced with ZwitterCo RO membranes, we managed to go up to 75% design recovery, which was originally intended value. The cleaning frequency that has gone down, and the cleaning was used to be carried out with the surfactant-based cleaning chemicals, whereas with the ZwitterCo membranes, we just flushing with the hot water. It's a fortnightly flushing, so a lot of savings on the cleaning chemicals. The operating pressure, it is to be in the range of 20 to 25 bar. With the ZwitterCo membrane, we managed to reduce it to 25%, around 16 bar. And the cleaning was carried out at 50 degrees Celsius hot water. With the ZwitterCo membranes, it used to be 35 to 40 degrees Celsius. Again, in terms of the support, we had very good support from the ZwitterCo team. As and when we required any support, whether it's any spares or any technical guidance, we used to get that. In terms of membrane availability, the original membrane supplier, they would take 3 to 4 weeks, whereas the ZwitterCo membranes has been always in stock. So that has been very helpful. So I got next case study where XMBR water is treated with the RO system. Esmil here supplied a system to treat XMBR water to make the water suitable for cooling tower makeup and to blend with the boiler feed RO system. However, upstream UF system was not always performing as designed, leaving a lot of organic slipping onto the membranes, RO membranes, causing organic fouling and frequent cleaning requirements. After consultation with ZwitterCo, Esmil replaced the membranes using the ZwitterCo RO membranes, of course, which greatly benefited the customer. So this application, the aim was to reduce the COD, run the RO plant continuously, and reduce the TDS so that it can be used as a cooling tower makeup water. And we managed to achieve that on consistent basis using a ZwitterCo membrane. To summarize the benefits of ZwitterCo membrane, again, we achieved the same or similar result as the case study one. Higher recovery, cleaning is carried out only with the hot water instead of surfactant-based cleaning chemicals, operating pressure, some reduction in the operating pressure. Again, a lot of saving on the cleaning temperature, heating requirements, and customer services supports always been fantastic. Yeah, so anti-fouling membrane, I mean, it has got a certain limit over the organics and the other foulants. And ZwitterCo, we found it can handle a lot higher organics, very high COD. And then before we decided, we did some quick lab testing using the 4040 modules, and we found that it's working well. There were no drop in the performance. The statistics was very good. So that was the reason we decided to go with ZwitterCo.